Hello, everyone, and welcome to HashiTalks. Today, I'll be talking about continuously deploying Terraform scripts with GitLab. Basically, we'll be talking about how we can write our Terraform scripts, and GitLab automatically runs checks on it, runs validation on it, and also runs the plan. And further ahead, we can also use GitLab to apply our infrastructure in such a way that it creates or updates the infrastructure on any cloud provider we choose. A little bit about myself. My name is Idowu Emehinola. I'm a site reliability engineer at Westwing. I'm also an HashiCorp certified Terraform associate, and I'm also a community builder, AWS community builder for container. Yeah, so let's jump right in. Today, I'll be introducing Terraform. I'll be reintroducing Terraform because I'm assuming that if you are here for this call or for this talk, you already have an idea of what Terraform does or what Terraform is. So just a quick reminder, a quick refresher before we go into the talk for today. Terraform is an open source infrastructure as code software tool that provides a consistent CLI workflow to manage hundreds of cloud services. So basically, this is the official definition for Terraform. Terraform, the goal for Terraform is just to be able to define your infrastructure as code in such a way that your infrastructure now goes through the end-to-end development lifecycle for a normal average application. Some of the concepts I'll be talking about in the demo later, for one of them is Terraform modules, right? You can see Terraform modules as a folder or a container, right? That contains multiple resources, multiple Terraform resources based on the cloud provider that you use together. So in such a way that it creates a light abstraction so that you can describe the infrastructure in terms of architecture rather than directly interacting with this physical object. So another concept I'll be talking about in the demo is Terraform workspaces. So what Terraform workspaces allows you to do is to be able to deploy similar or the same set of Terraform scripts in different environments, in such a way that based on the environment, some configurations changes, but the core of the Terraform script itself would remain the same, and that helps with avoiding code duplication between environments. This is just a visual representation of what we have. So you see over here, we have our Terraform script, the same script, but we're using a specified workspace. We can deploy this script with customized values into the development environment, a staging environment, or a production environment. And this works seamlessly, right? Also, I'll be introducing, I would like to talk about how quickly your Terraform script can grow, right? Say you start off by learning Terraform, you create a few .tf files, you're playing around. When you want to deploy to production or when you start using Terraform within your company, you notice that okay, you need more things. You need a module. You need to deploy not just an EC2 instance, but you also need to deploy an RDS database instance. So gradually, your Terraform script begins to grow, and you move from a small size Terraform script where you just have main.tf, output.tf, and variables.tf, just 3 files, to a medium-sized Terraform code base where infrastructure now you need to manage it with Terraform workspace, you start creating modules and things like that. And before you know, you want to segregate these things into projects or applications, and your Terraform script is getting larger, right? Now, this becomes difficult to manage because in this kind of folder structure or code base, you need to manage infrastructure for a particular application or a particular project. You need to manage infrastructure for another project, right? And with this, it means you need to be in all these folders, run a Terraform plan, run a Terraform apply to make changes for application 1. Application 2, you have to do the same. That is why we need a CI that helps automate this process, and we can actually see the better part of this in the demo. Talking about GitLab CI, we will be focusing on just 4 stages in our GitLab pipeline, and these stages are the format check. So first of all, we want to check, is this code base in a recursive format? Is this Terraform code base is it in a standardized style when as far as Terraform is concerned? We also want the next stage will be validation. How do we validate that what we have written is a valid Terraform configuration? So that stage helps with checks and just code quality. The first two stages helps with code quality, and it helps us know the state of our Terraform script. The next stage will be Terraform plan, which is the renowned command to know, which is the renowned command to know, to show the changes of the current configuration. How does this change I've made to my Terraform script apply to the existing infrastructure? Does it delete something? Does it create? Does it update? So the Terraform plan allows us to know that. And Terraform apply, which is the last stage, it actually attempts to create or update the existing infrastructure that we are managing using Terraform. To show this in a diagram of our template, our template will go. The first stage is the format check, and the next one is Terraform validate, which validates our configuration. We also have Terraform plan, we also have Terraform apply. Now, I added a little bit of, in quote now, gymnastics to the Terraform apply, Terraform plan stage in such a way that once you have Terraform plan for each of these infrastructure, instead of going into the pipeline to check them individually, the changes from your Terraform plan would be added as discussions to your merge request. So that way, it is easy, code is easy to review, and concerns are easily raised. Now we'll be going into the demo. First, I'll be explaining the folder structure that I currently have, and I would also be showing you how creating a pull request, what happens after creating a pull request, how we apply, and how changes reflect on the cloud provider. All right, I'm going into my code now. You should be able to see my VS Code right now. So currently we have basically majorly 3 important folders. But before I talk about the folders, I would like to talk about the GitLab CI configuration. So if you see this, you will see that we have something very unique here, which is the parallel. I'm going to talk about that. And then we are referencing individual files for each of these stages. And also, you will see that we're using the Terraform image, the official Terraform image of version 0.14.4. Now, talking about parallel, basically, this is a GitLab CI keyword that helps run jobs, multiple jobs in a combination of each other. So basically, what this translates to is it runs app1 for every environment variable set here. It runs a pipeline, an individual job for stage app1. So it does like a combination and says, let me just do this. So it runs for stage app1. It also runs for stage app2. The same thing happens for production. However, for production, we're only deploying app one. So this is a way of me showing that, okay, we can also decide to deploy some applications for just staging, and some application for just production, and some for both. Right? Yeah. So, and I'll be walking through this GitLab stages one by one, and we can all see how this builds up quickly before we then make a PR, then see what we have. Yeah, our CI, the first thing is the format. Basically, what we are doing here is just a check. Okay, our pipeline, does it, our Terraform script, sorry, does it conform to the standardized configuration? Does it just general code quality? And this only happens on merge request, and this is what line 9 and line 8 tries to do. Then we have Terraform validate. Terraform validate basically goes through, does a Terraform init, selects the appropriate workspace, which we have defined in the GitLab CI. So we have this workspace already created for each of the applications. We have stage and we have production to deploy applications to staging and production, two environments, the same Terraform script. And we are automatically selecting the workspace here. Of course, we are referencing parallel, but we're referencing each of these combinations: stage app 1, stage app 2, app 1 production, just like we have it defined here, here in this section. So we have we are selecting the appropriate workspace for each of them. We're using the workspace variable that we have here, and we are also doing a validate based on the application directory. So we are doing init, selecting the appropriate workspace, and doing a validate. If the validation is wrong, or if the Terraform configuration is not valid, this stage fails and the whole pipeline fails. Then we have a Terraform plan. This is kind of a bulky stage, so I'll kind of spend a minute here to explain what we're trying to do. So first, we are installing all the necessary dependencies we need. We are changing directly into the appropriate app directory that we need, and immediately running a Terraform init within that. This step is an additional step in the bit to generate a report after we are done with the plan. I'll try to show you that step on the GitHub platform. Then we are also selecting the appropriate workspace, running a Terraform init, and running a Terraform plan based on using the values file, and then outputting the Terraform plan into another file, basically. Now, based on the results of this stage, if it is 0, it means no changes found. That's the exit code Terraform returns. If it is 1, it means there's an error somewhere and we need to exit. If it is 2, it means there are changes found, and basically we want to print these changes in a customized format as a discussion on the pull request. Basically, what we are doing is echoing the job name into a file, and this is the file we are sending as a message to the GitLab API. And we are also running the diff command so that it is well formatted. Then we run a Terraform show. Basically, we're running a show on the file we generated at this point during the Terraform plan command. Doing a little bit of formatting at this stage, and at this point, basically what we are doing is sending all these changes we've made using the GitLab token and every other configuration, every other pre-built, inbuilt environment variable for GitLab CI. We're sending this as a request, and this will make our plan created as a discussion on the pull request. Now, immediately after this, the next thing we are doing is so that when we want to run apply, the plan is not regenerated. So we are sure it doesn't change over time. We are saving this as an artifact. So the plan generated from the Terraform plan command is saved as an artifact and sent to the Terraform apply command, so that apply would not, the apply command just runs the apply based on the file we have generated. And we can see this on the apply stage, which is very slim. Basically, what we are doing is we're doing a Terraform apply on the file generated from the artifact, which we are getting at this stage. Now I will quickly, and of course, this is a manual step. We don't want to deploy or run Terraform apply upon every change. We want to make sure we have reviewed. We want to make sure we are sure, and we want to make sure it is intentional. That's why this stage is a manual. This step or this stage is a manual stage. Now going quickly into the Terraform folder structure, we have application 1, we have application 2, and basically application N is just to show that this application names or the number of applications can grow from 1 to any given number. So that's why we have this empty folder here. And then we have the modules folder, which holds S3 module, which we are using in one of our applications. Application 1 basically deploys an S3 bucket using the module. And and since we are using workspaces, this variable is available to us. So based on the workspace, the S3 bucket name changes, right? And application 2, basically what application 2 does is to deploy a DynamoDB table. As we have configured it, it's a very simple DynamoDB table. We are also using the workspace variable here, which is available because we have created workspaces. We have every other thing is your standard Terraform file, TF file. However, based on the stage, right, we are setting tags. So basically, what I'm trying to show here is that based on the stage, we can easily change variables, right? In this case, we are only changing the tags. Majorly the difference is environment here is production and environment here is stage. And in this case, what we have is this can grow as large as having feature flags that okay, we want to deploy, say, a DB for only staging, and we don't want to deploy for production, and we can customize this as much as we can. So I'll be going ahead now. So since we made a change to our GitLab CI, I'll be going ahead now to quickly commit this change, and once this change is committed, we'll create a merge request and see how the pipeline runs. And once the pipeline is running, we would be able to see the changes, merge the merge request, and then see how we can apply these changes to AWS. So in this case, I almost forgot. We're using Terraform backend also. In this case, we're using Terraform. We're using AWS S3 as our backend. We could also use GitLab as our Terraform to store our Terraform backend, our Terraform state. We could also use the Terraform Cloud platform to actually save our state. So this option depends on what your preference, basically. So I'm making a quick commit here. Add comments to CI file. I'm doing a quick push to development. All right, GitLab is misbehaving. Okay, I think I'm not connected to the internet. Just give me a minute. All right, trying again. Awesome. So we have our code pushed, and on the GitLab platform, basically we can easily create a merge request. And then click on create. So basically this triggers the pipeline that first, I'm opening this in a different tab. The first does a Terraform lint, basically checks the format, make sure for every file, make sure it is standardized in a standardized format. And once this is good, it moves to the next one, which is to validate. And like we can see here, you would see that we actually have 3 jobs running. You'll see we have Terraform validate, and then something interesting. We have production, which is the state, and which is the workspace we define at this point, which is the workspace we defined at, which is one of the workspaces we defined at this point. So we have production, and then the app directory in this case. And secondly, if you go here, you will see we have stage, app 1, which is the app directory. And lastly, you see stage, app 2, because we said we configured 2 application directory for stage and just 1 for production. And this seems to have gone through. I'm just going to give this a little refresh. And we see that our validate is working as expected. And then we go to the plan. And you see that this also, because of the parallel keyword, this also goes with the same format. And one beautiful thing we would see here is, as the plan is running, we would begin to see this, the plan, the output of this plan being added as discussion to our pull request, basically. And the job name is added here, so you don't confuse which application is which or which stage is which. So this is a create resource. We see that we are creating an S3 bucket. We can see all the tags, we can see all the configuration, and this prints for every one of them. And this makes code review of your Terraform script easier. So I'm going to go ahead to merge this so that we can actually see the Terraform apply stage, and then appreciate that. So merging this fresh now. Okay, I think the problem. Okay, I think GitLab is misbehaving. Just give it a quick refresh there. Yeah. So we've merged, and when we come to the pipe, the CI point, we'll see that we're running another plan for each of our application. So for production, for staging, and yeah, for staging for the other application. So this would run for a bit. Once it's done, we can then manually make changes or manually trigger each of the Terraform apply job for each of the application and workspace. Okay, just giving this a bit of time. Okay, this is done. Then we are waiting for the last one. Awesome. So so I'll be doing a Terraform apply now. So I'll start with product, or anyone can start with this. And we can, so this is production app 1, which creates S3 bucket. We can actually see that on the AWS console. Basically, I'll also be showing that. So currently we don't have any Terraform bucket created apart from the one we're using for our backend. So if I give this a quick refresh, okay, still loading. Another interesting thing about this is I can also just trigger the remaining, and they don't affect each other because we have segregated the backends and they don't affect each other anyway. And also trigger the last one. And awesome, this is done and successful. So we have app 1 production, and which is the name we configured for the S3 bucket. We have local.application, then the stage name and local application can be found here, which is just the application name, app 1. And if we come to S3, we can actually see production app 1 here already created. We can go through the tags and see it is actually environment, production, and every other tag we specified. And also checking the other stages. So this is done, and every one of them is done. So just checking this again, you would see, if I give this a quick refresh, you will see that we have app 1 stage, app 1 production, and also in the same vein, if we check DynamoDB, you would see that we have a table here called app 2 stage, basically. So that shows us an end-to-end flow of how we can use GitLab and the power of its parallel concurrency, basically to manage a very complex Terraform code base. This can span as much as several nested folders or applications, depending on the complexity of the application, and we can ensure that our Terraform script is being reviewed appropriately and correctly. The formats adheres to standard formats, and our configuration is valid. So just to make a quick change here, so that we just create another PR and see the pipeline in action again. I can make a quick change to say stage and say stage test, for instance. I give this a quick push. Awesome. And I can create a new merge request. And we'll see this flow starts all over again. The format is checked, the validation is checked, the plan is done, and discussions are created on this new merge request, and we only see the changes, the changes we have made, and what we want to do, basically. So I will come back to this in a bit. Just as a summary, basically the whole idea of this talk is to show that GitLab CI can be easily configured in such a way that it makes deploying Terraform scripts, Terraform code base, no matter how complex they may be, or no matter how many gymnastics we want to do, it makes the flow easier. It makes it actually work in such a way that we are in control of what happens to our Terraform script. Yeah. Thank you very much for joining me. I would be on standby for questions now. And just before we go, we can just check our running pipeline. Yeah, we're on the plan stage. We can just wait for this a bit, and you would see discussions will start coming in no time. I would entertain questions now while we wait for this to complete. Okay, we have some of them already done, and then we can go to the merge request. And voila, We have it right here. Tags, just the changes, and it is well appropriated, updates in place, giving us the details of what is changing. And if this will cause a breaking change, we can reply to this, draw the attention of the person creating the ticket, the merge request, and get a result. Thank you very much for joining me for this talk. I hope you enjoyed this as much as I did. Thank you very much.